Here's a calculus exercise that applies the tangent problem, which is the forerunner to understanding limits, which is the forerunner to understanding derivatives, which is the first part of calculus. So in this exercise, it says that a tank holds 1,000 gallons of water, which drains from the bottom of the tank in half an hour. The values in the table show the volume V of water remaining in the tank in gallons after t minutes. So here you have that table. You have t minutes and the volume that is remaining in the tank at that minute. Here you have a sketch of that curve, and you have a Cartesian plane like an xy plane, only we use t and v as the variables here for time and volume respectively, where t is the independent variable and v is the dependent variable. It depends on the value that we input for t. So initially at 0 minutes you have 1,000 gallons, just like what the problem tells us. And after 5 minutes you're left with 694 gallons, and so on according to the time. And now we're asked in this two-part problem, if p is the point 15 to 50 on the graph of v, find the slopes of the secant line PQ when Q is the point on the graph with, and so we're going to do this 5 times, when t equals 5, t equals 10, t equals 20, t equals 25, and t equals 30. So here we have the point 15 and 250 right here, so that is the point P. Now the whole point of what we're trying to do ultimately is in the second part of the problem. Estimate the slope of the tangent line at P by averaging the slopes of the two secant lines. Well, as we move forward with calculus, the point of the first part of calculus is to finding the slope of the tangent line without estimating. It helps us to lay out the foundation of what we're doing. So here's the tangent line at point P. Now again, tangent comes from the Latin meaning touching, and this tangent line touches the point P at one point. Okay, but as we remember, we cannot find the slope of a line because we have to have 2 points. Therefore, we have to draw out a couple of secant lines and then find out an approximate slope and then take the average of the two. So let's start with part A, and with the first time when t equals 5 minutes. So the point P is at 15 to 50. Okay, so our first Q would be at the point t equals 5, which is right here. And so Q, which I'm going to denote as Q1, will be the point 694. So here's the point Q1 right here at 694. And I'm going to draw the secant line. Okay, so secant, again, recall, comes from a Latin word meaning cutting, or at least that's one definition, just cutting through 2 points right here, PQ. Alright, so to solve this, to find the rise over the run, to find the slope, you have to recall the formula. The slope is the change of y over the change of x, which equals y2 minus y1 over x2 minus x1. And see, we have the rise and the run. So we have delta y and delta x. So the slope for the first secant line is going to equal, well, let's call this x1 y1, and let's call this x2 y2. So it's y2 minus y1 over x2 minus x1. And I've already pre-calculated the numbers, so that's 444 over negative 10, and therefore the slope of this secant line is going to be negative 44.4. So that is the slope of the secant line PQ1, as I'll denote it. So the slope is negative because it's going in the negative direction. Now let's go on to part B, where t equals 10 minutes. So our P is going to be the same, 15 to 50. And Q2 this time, we're going to do 10 minutes, 10, and that's 444. And that is that point right here. So this is Q2. Okay, so I'm going to come in and draw the secant line right here. And you would notice that went from here to there. So I'm going to predict that the slope is going to be greater. And eventually, if we kept on going, and if this would curve upward, it would eventually get to 0 and then a positive slope. So if the slope starts out like this and then comes in this direction, we know that it's going to get greater and greater because this is 0 and this is a positive slope. So I'm going to predict that this is going to be greater. The slope is going to be y2 minus y1 over x2 minus x1, and that's going to equal 194 over negative 5, which equals negative 38.8, and that's the slope of the secant line, PQ2, as I'll denote it. And let's go on to letter C. This is where t equals 20 minutes. We cannot put the point at 15 because then that would be the same point, therefore the same line, and you need 2 points to find slope. So P is going to be the same, and Q3 is going to be 20. When T is 20, V is 111. So that means after 20 minutes there's 111 gallons remaining. So Q3 is this point right here. Okay, I'm going to connect it here, which I predict is going to be even greater than PQ2. I'll stop drawing the secant lines right there as you get the picture. The slope is going to be y2 minus y1 over x2 minus x1. Okay, and so that's going to be negative 139 over 5, which is going to equal negative 27.8 right here. That's the slope of the secant line PQ3, and it is getting greater and greater. So now D is where T equals 25. Our P remains the same. Q4 is going to be 25, and as we see, when it's 25 minutes in, there's 28 gallons remaining. And so our slope is going to be y2 minus y1 over x2 x1, and that's going to equal negative 222 over 10, which is negative 22.2. That is the slope of the secant line PQ sub 4. And now part E, where T is 30 minutes. Okay, so P is going to be 15 to 50, and Q5 is going to be 30 and 0. As it says, a tank holds 1,000 gallons of water and it drains completely after 30 minutes. So the slope is going to be y2 minus y1 over x2 minus x1. It's going to be negative 250 over 15. For this one, the slope is going to be negative 16.6 with an overbar on top. And that is the secant line the slope of the secant line P Q5. So now for part B, it says to estimate the slope of the tangent line at P by averaging the slopes of two secant lines. Well, I'm going to choose Q2 and Q3 since those are the two nearest T values that we have, and so that will get us to a more precise answer. PQ2 and PQ3. And to average them, these 2 points, I'm going to add them together, take the sum, and divide by 2, which equals negative 38.8 plus negative 27.8 divided by 2, and that comes out to be negative 33.3, or negative 33 1/3. And as it turns out, that is the slope of the tangent line at point P. Now this calculus exercise, which is in the first chapter or two, depending on the author of your textbook, and it helps reinforce the idea of the tangent line. And from here, you'll learn more about limits, and from there, derivatives, where you don't need to do such estimations and you could get to a more precise answer. So before concluding this video, I feel that it's highly imperative for me to explain what the heck do these numbers mean? What does it mean when we are finding the slope? Well, to find the slope means that we're finding a rate of change. But what do these numbers mean? Why is it so important to find the slope at the point 15, 250, or any point for that matter, of this curve? What would that tell us? Well, recall that the slope is the change of y over the change of x. Therefore, our slope is in terms of delta y over delta x, and in units that is gallons per minute. Therefore, when we find the slope right here, which is negative 33.3, this represents 33.3 gallons a minute that the tank is draining of this water at this point, at exactly 15 minutes. However, if we're up here and we do the same thing to find the tangent line of the point 5,694, we could find out the rate at which the tank is draining the water up here. So therefore, this red line right here, which later we'll call the derivative, is in fact the rate at which the tank is draining the water in gallons per minute. So as water in a tank drains, what is the rate at 15 minutes? And that is the purpose, that's one of the purposes and applications to differential calculus, to taking derivatives and everything. That is one of the purposes of this. So while you're taking this class, what your major is, just don't give up on them. Really, calculus is easy, and it's even more easy if you understand exactly what you're doing and what these numbers mean. So just don't give up on what you want to do. I assume this is the beginning of your semester. I'm assuming that you're taking, starting out the semester. So I hope you have an enjoyable semester, and have a great day.